Okay, so here's problem number 21 from section 10.1. Sketch the curve on the given t interval and indicate the direction in which it's being traced. Now, what I'd like to do is spend a moment taking this back into the time that we're comfortable with and most familiar with. And that is, I'd like to take a look at this as just an XY problem. I know, for example, that it's a fact that sine squared t plus cosine squared t equals 1 is a fact for all values t.
Yes.
Right? And because x is sine t, I might say that x over 2, since x is 2 sine t, I might say that x over 2 is sine t, and I can replace that with x over 2 quantity squared. So far, so good?
Yes. Are we going to use the bring it on up rule? Which doesn't exist, but is a replacement.
This is done.
This is.
Yeah. Not a problem. All right, bye. Vicky, Mr. Beebe would like to see you.
Oh, man.
All right. Now, the other thing I'm going to do, because this doesn't say cosine or a multiple of cosine, it's cosine 2t, I'm going to break out the power reducing rule again.
Yeah. What does it say? Cosine.
Oh, I'm sorry.
Do it backwards.
The rule is
Yep.
that cosine squared of t is equal to 1/2 plus 1/2 cosine of 2t. If I solve this for 2t, I get cosine squared of t minus 1/2 is equal to 1/2 cosine 2t, or 2 cosine squared t
Minus 1.
minus 1 is equal to cosine of 2t.
Okay.
So, that is why, right?
Yeah,
Yeah.
that's why. So since y equals cosine 2t, y equals 2 cosine squared t minus 1. I said it first, you better.
I don't think you
Doesn't,
did.
it's not a race.
Right?
Far.
No, I'm sorry. I did all this work solving for cosine 2t. I didn't need that. I'm going to replace this in here. It's equal to that.
Now you replace cosine 2t with y.
And
So it's 1/2 plus 1/2 y.
Righto.
this is y. 1/2 plus 1/2 y. Right?
Yes.
Yeah.
It's a little easier.
Yeah, there we go. So, plus this is going to be replaced with 1 plus 1/2 y. And it's equal to 1.
Y.
No.
No,
It's
no,
cosine
because
squared
cosine
equals
squared
that.
is all of that. All right.
Yeah.
So that power reducing formula comes to our rescue again. It must be so important that we should memorize it. All right. So if I do a little bit more work on this, let's say x squared over 4. Let's take that negative half over to the other side. So 1/2 y, and this equals to 1/2. I hate fractions, so let's multiply both sides by 4. I get x squared.
Plus.
Actually, no, I just will multiply it by 2. Because that's going to get a y by itself. And now I get y is equal to 1 minus x squared over 2. And now from that form, you're like, oh, I know what shape that is. It's a graph.
Very,
True.
Very solid conclusion. Man.
But
I think we can.
I don't think it's a solid.
something
I
a
think
little
it's
more.
A little bit more specific.
There's a line that's.
Yeah, there's a line.
It's a parabola. It's not really a parabola, but it's a parabola that's pointing
Down.
down.
What number are we doing?
Negative x squared, down.
This is 21.
All right?
That is right.
So this is a parabola that when x is 0, y is 1, and then it points downward. Now, that's what it does. That's what it does without restrictions. But we know that we actually have restrictions on t, so only a portion of this parabola is part of that graph. and this is where I want to switch over to the technology. Let me get in parametric mode.
Par.
We can use our calculator.
Well, I want to make a very interesting point, a possibly interesting point. I want to say something. What was this, sine of t? Is that right?
Yeah.
Could be.
And what was this, cosine of 2t?
Yeah.
X equals 2 sine t.
Oh yeah, it's two. It's two sine t.
Second insert.
Yeah, I remember where the insert doing that. Yes.
All right. And on my window, I want to make sure that we're
1.5 to 4.5. What's the t step thing?
This is how much space is there between each t as you're doing the thing. If it's really, really big, it's going to give you not a very accurate. But if it's small, then it says, I start with t equal 1.5, I get a point.
And the point is that far away.
Okay, and then I get an xy. Let's make this 0.1. Then I go and make t 1.6. I get a new xy, and I draw the little line between the
It's
two
that
points.
Euler's method thing, sort of.
Yeah, I think you can make that
Oh,
analogy.
Euler's? Yeah.
Euler.
Euler.
I don't know. Euler.
I like Euler
Okay.
better.
Does that look like the parabola that we're talking about?
Edmonton Eulers.
Yeah. No, it's spelled differently. So they're the
It doesn't even
Oilers.
fit. It puts it like exactly.
What, did we have an error?
We had an not an error.
It graphed it fine and
It
then.
said errors.
What's it fit?
Oh, it's 0.
0?
Wish I grabbed it.
I should memorize that.
What?
Okay, so yeah, that looks like a parabola.
Yeah, it does.
I said pointing up as in that way.
Pointing up as in down.
All right,
I like it.
now that's from 1.5 to 4.5. What I think is really cool here is that I'm going to do a couple more things. I'm going to make this a football trace.
The heck is a football tree?
A football trace is that it's going to draw the line, but then it's going to have a little football that shows where we're graphing at any given point.
Is it the official
Football that
name?
you throw.
The official name.
And then the other thing I'm going to do is I'm actually going to make this go much
The
longer,
official graphing method of the NFL.
so that you can appreciate what this is going on.
Oh, look at that spiral. It's beautiful.
So because of the sine and the cosine, there's actually a periodic behavior here. It'll go and bounce back and forth between these points.
Is it drawing?
No, well, it's drawing a little bit. There's a little bit of error because it's using 0.1 as a step. And so there's a little bit of, just so you can see the periodic nature. So this is like, you know,
It's getting thicker.
boom, boom.
It's like kicking one.
It's
It's
one of
kicking
those-
a ball back and forth.
Okay. So you,
Punch,
so just to
punch.
see, when you see sines and cosines, I want you to think about that periodic nature that those functions have.
Catch.
How come it's getting
Punch.
Okay. I think that's enough for now.
Oh, it's getting.
It's getting thicker again because of the error in the
Yeah.
cosine. All right. So, if we go back to the problem as it was stated, yes, it's a parabola, but the graph allowed us to say what's going to go on is that this parabola on this bound gets drawn in that direction.
Whoa.
All right.
Yes.
So the requested point, they would like to know what the highest point is.
Whatever it is at 5.
0.
It's 0, 1, and we're reading that
Yeah.
off of that XY version of our graph.
Yes.
Now, can we do part C? Can we justify that the highest point is at 0, 1 by analyzing the appropriate derivative?
I'm sure we could.
Yes, we can.
Well, we don't have.
Yeah, we do.
As
So-
Bob the Builder would say.
As Bob would say, yes, we can. All right, so what do we got? Cosine, y, I want to find the derivative of y with respect to,
Negative 2.
T.
Negative.
Negative
Negative
2
two.
sine 2t.
Thank you, Richard.
Don't forget the chain rule.
Say chain rule song last time.
okay,
Yes.
that's good? All right. Now, I would like to find out whether the derivative satisfy this. Now I could go ahead and write out the whole dy dx thing, but when I'm trying to find the highest point, which happens when we have a horizontal tangent, which happens when the numerator of the dy dx
Zero.
Is
is 0, why do we even need to mess with the dx dt?
We don't.
We don't. So we're not gonna.
Set that equals 0.
So I'm interested in the question, when does negative 2 sine 2t equal 0? Okay, this happens, this is equal to 0 when sine of 2t equals to 0. Now normally we think about sine of, let's say sine of u is equal to 0 when u is 0, pi, 2 pi, or essentially whole integer values of pi. But it's 2t.
So pi over 2.
So sine of 2t is equal to 0 when t is equal to 0 pi over 2 pi,
Integer
2 pi over
Yeah.
2, 3 pi over 2, or we could say that that is n pi over 2, n is an integer. Are we okay with that?
Yeah.
Okay, let's put all the pieces together then. I need a value for t that's in that bound.
Okay, great.
Is it 0?
No. I don't
It's like,
think
this is
so.
like 1 point,
Yeah, it is. It's a little-
1.7?
Yeah, that works.
Okay.
Which
In
one's
so-
pi?
Or to be sure, pi, because we know that.
Pi is definitely, yeah.
They both are.
Okay, so both of those are candidates?
Yes.
Okay.
Draw that number line thingy. That we
Well-
do the positive, negative, positive.
You know what?
I was hoping we could just leave it at
No, there's gonna be a problem that we're gonna need to deal with. We're gonna do both of them, and I'll show you why. All right? Let's find out what's going on at pi over 2. At pi over 2, x is equal to 2 times sine of pi over 2.
So 2 root 2 over 2.
2.
So root 2.
X is equal to 2.
Or no.
What?
Sine
Oh.
of pi,
Wait,
2
sine
pi
of
over
2,
2.
sine of pi over 2 is 1, isn't it?
No, sine of 2 pi over 2, isn't it?
Oh, pi over 2,
Maybe
not
2
pi
sine
over
pi.
4.
What is sine of pi over 2?
Sine of pi over 2 is 1.
Sine of pi, it should just be 1.
Yeah, 1 times 2, which is 2. That doesn't look like x is equal to. That doesn't look like x is equal to.
0.
So it would be 2 sine pi.
So
5. Doesn't look like
it's
x
saying
equals
the
5.
point that's on 1, 0.
It's just stating all the
Pi over
points
2.
that x was
Well,
not.
sine of pi is 0, so that works.
What do we plug in to get
X
pi
is
over
not
2?
3,000.
Hold on.
It's not.
When t is pi over 2, you're at the point 1, 0. Or nearby that point anyway.
Not 1, 0, 0, 1. We just need to find
Sine of pi is 0.
I'm
x
saying
is
if
0,
pi over
which
2
is
doesn't
at
make
2
0
sine pi.
Oh, wait,
There you go.
Yeah, pi.
According over.
So you're saying it's
Get out.
Trace.
Bam.
Oh. Ah!
Ah,
And it hits a bird.
You can't intercept the football when they're trying to play catch. Mr. Fisher.
Boom.
Okay. Trace. Now I can put values in for t. Pi over 2.
Why?
Uno punto cinco.
X equals 2, y equals -1.
That's not even in the range.
That's not right.
Wait a minute.
It's too, no, it's too far right.
Wait a minute. Are the, in the original problem, are the values given by in
What?
values of x or in
Amazing.
values of
Yeah,
better.
pi.
or in values of t?
Say that again.
In the original problem, are the values given in
Values of t.
values of t?
So what's going on? This seems contradictory.
Does it?
Well, we put in pi over 2. It doesn't put us in a spot where I expected.
No, it doesn't.
But when we put in pi,
It
it
doesn't.
seems okay.
False lead.
Is it false lead? Here's what I think is going on. This is what I think is going on. I think this point right here is the point 2, negative 1.
Looks like they
I think this point over here is negative 2, negative 1.
have. Okay.
Right? I think when we start at t equal 1.5, we start here. It goes down to this point at t equal pi over 2. Then it starts up and reaches there at t equal pi.
Okay.
That was confusing.
Yeah. Very confused.
So when we solve this to make it equal to 0, except it's equal to 0 there, but there's more going on there. You want to know what else is going on there?
Yes.
The derivative doesn't exist there.
A cusp.
It's a cusp because the particle totally changes direction there. How would I know that the derivative doesn't exist there? I'm going to
Solve
bet
dx
if I
dt.
find dx dt,
It's gonna be 0.
it's going to be 0 at that point.
Oh, bam. Someone's at the door.
Who's the door?
Hello.
Okay, you can let it. More efficient.
Nope.
Maybe he didn't want you to bring another pick. He just walked in. But I just said.
I mean,
No.
looking
Still
good.
turn thing.
Okay, so the derivative of x with respect to t is 2 cosine t,
I agree.
Cosine is 0 at pi over.
and at t equal pi over 2, which was that first place that we thought that the highest point could be,
Oh, I found this.
dx dt is, well, dx dt is 0, which means that dy dx is undefined. All right, so that's why the pi over 2 answer doesn't make any sense. And we have used in the derivative to confirm that here it is, because at pi, at t equal pi, this value is, sorry, dx dt is 2 cosine pi, cosine at pi is negative 1. So it's negative 2. At pi, when t is equal to pi, dy dx is defined, it is 0, and that explains why we get this
That
sort of
is the
weird,
right answer.
yeah.
So it does dip down.
I got it.
Alright.
And we could do one more thing to confirm that.
Technology.
Let's do it.
This is.
Second problem.
You might be able to do like half of the next one. At this rate.
And I'll even make this pretty small.
0, 0, 0.
You can barely see it there, but I bet you if I do a zoom,
Gotta quit out. Second.
zoom, what's going on here?
You have to quit out. It's thinking. Oh, thank you.
Zoom fit.
Line it down.
What? Where's that?
going down the side with.
What was that?
What the?
Up here, this was at t equal 1.5. Down here,
Oh, I see. T equals pi over 2.
so I looked at that very small instance of time just before it reached pi over 2. And what did you see? You saw the football going down,
And then it goes back up after
and
you
then
can't
it
see
goes
it.
back up.
Gosh, this is a weird problem.
in the air,
So if you
comes
leave
down.
this window at this, and you go back to.
You're sure these are going
Go
down?
back
Get Boston.
to
Could
the
you have done that
down,
idea?
then go back up.
I don't think I did do that on my notes. I did, but I couldn't have figured that out. I mean, no, you see, I got the right answer.
I wouldn't even go that far. I'll go to 2. Down, 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 down. Almost to pi over 2, almost to pi over 2, almost to pi over 2. Pi over 2.
Let me go. Go back up.
And there it is. You did it complete. Okay. Well, you know what, Jordan? I'm all about easier. Okay.
And that's
You're
not
looking
it.
for a relative maximum. All they did was
Wait.
find
Oh, we still got a recording going on.
We're still recording.
Wow, yeah.
So whatever you guys are talking about,
It's
I'd
going.
really like you to pay attention because Jordan is going to be amazingly insightful.
all they did was find dy dt, which is negative 2 sine 2t, and they just found where it goes from positive to negative. Or maybe the other way, I don't know, but it's at pi. And then
So, but you're telling me that negative 2 sine 2t does not go from negative to positive at pi over 2? I'm pretty sure it does.
It should go from
It says-
Oh, it goes
positive to
from
negative.
negative. It goes from
Positive to negative, because it's a maximum.
Yeah, Jordan.
Oh.
I was just looking at the thing.
So, we just confused ourselves. Is that what
Okay.
we're saying?
So dy dt does have a 0 at pi over 2. It does have a 0 at pi. And on this range, negative sine 2t is negative. On this range, it's positive. And on this range, it's or best of that, it's negative.
Yeah.
So, of course, there's no highest point here.
Right. Because it's a negative.
Because dy is falling from pi over 2 to pi.
And then someone kicks
It's
it.
rising. And then when we get to pi, what happens it does?
Falls down.
It tilts.
So we ended
What
up,
does it do? It falls again.
so we ended up making the chart.
So we made the chart anyway.
After all that.
After all that. Okay, you know what this means? I don't know. And then
Yes!
Okay, there we go. We're back.